Today we're going to start chapter 11, which has to do with roots. We're used to the typical square root that looks similar like to this. The square root of 4, as we know, is the same as 2 times 2. So that means the square root of 4 is 2. We think of the square root of 16 equals 4 because 4 squared equals 16. But we're going to look at other roots besides only cubed roots. Your calculator is going to come in handy, so make sure you have it out. On your calculator, if you want to find the square root of something, you use this button. That button automatically does the square, so something like this. You push the square button and then your 4, and it will equal 2. If you want to use the fourth root of something, you hit Shift and then this. Notice it'll give you something that looks like this and like this. If we wanted the fourth root of 81, we would push that button, we would put a 4 in here and an 81 here, and we would get the answer 3. And what that tells us is that 3 to the 4th power equals 81. Some of these you may know, especially when it comes to cubes, but a lot of these you won't, so your calculator is very useful for this. There are some special circumstances we need to consider when we're thinking about roots. The first one we want to look at is if we do -2 times -2, that gives us +4, right? So because of that, we cannot have the square root of -4 because nothing times itself equals -4. If we have -2 times -2 times -2, though, this equals +4 times -2, which is going to be -8. So we can have a cube root of -8. You can see a pattern here with the fact that this is an even number, this is an odd number. Odds will turn out, if it's negative, odds will turn out to be negative. Evens will turn out to be positive, so you cannot have a negative inside a square root. Let's next look at a fraction inside a root. Let's do the cubed root of -27 over 125. We're going to look at cubed roots, and the cube root of 27 happens to be 3. The cube root of -27 happens to be 3. And the cube root of 125 happens to be -5. Therefore, our cube root, we can use the negative, and we just find each portion, and it's -3 over 5. We have some numbers that are not perfect squares or perfect cubes, and in that case, we need to learn how to estimate those problems. So let's look at the square root of 129. There is no square root of 129, but there is a square root of 121, and there is a square root of 144. Those are the two on each side of 129, the below 129, above 129. So what we say is the square root of 129 is less than the square root of the square root of 121 is less than the square root of 129 is less than the square root of 144, or we could also say that it is 11 is less than the square root of 129 is less than 12. So we know that the square root of 129 comes somewhere between 11 and 12. Let's look at another one. This time we're estimating the cubed root of 50. The cubed root of 50. Okay, so we're going to look at our cubed root chart, which we have at the front of the room. We're going to look at our cubed root chart, and we can see that the cube root of 27 comes in between the cubed root of 50, and then above that is the cube root of 64. In other words, this is 3 is less than the cubed root of 50 is less than 4. You can also use your calculator to actually put this into your calculator. So what you're going to do is, if you're estimating, you know it becomes between 3 and 4. If you're supposed to give an exact answer, you need to put it in your calculator. Remember your sign that looks like this. You put in square root of the cube root of 50, and you do equals, and it will come out to approximately 3.684. And that's how you can use your calculator to find exact square roots or cubed roots or any root you're trying to find out. Okay, let's look at this number, 5 to the exponent of 2 over 3. We have this special format in which if we have x to the a over b, it's the same as saying the b root of x to the a power, or you could also say the b root of x to the a power, like this. So when we look at this specific number and we want to convert to radical form, we're going to put our 5 inside, and our denominator, the 3, is our b, and this is our a, right? Notice our b goes on the outside, and our a goes on the inside. So then we can actually look at, we can simplify this to be the cubed root of 25, because 5 squared is 25. And the cubed root of 25 is not, we cannot simplify it. There is no perfect cube. So this is our answer. Now let's look at a number in radical form. If we have 5 to the nx to the third power, again, x is our number here, and it's to the third power over 5. This is our a, which goes on top, and this is our b, which goes on bottom. So if we have a radical, so this is our answer right here. So if we have a radical with an exponent and we want to put it in exponential form, then this is what we're going to do. If we have our if we have our exponential form and we want to turn it into radical form, then this is how we go about the process.